Hey guys, so in this video I am going to go over our Unit 5's test review. I'm going to kind of do it short and sweet. You should be able to do most of these, but I have chosen some of them to go over with you. So before we can do 1 or 2, we need to create our Pascal's triangle. How you create your Pascal's triangle is the first and the last of each row is going to be 1, and you're going to start off with 1. So each time you go down, you're going to add a number. You can go down for a while. Once you create your first of your row and your last of your row, you can fill it in by adding the 2 numbers above it to get your middle numbers. So 1 plus 1 is 2. 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And you keep going. 4 plus 1 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. And you could keep going forever and ever. How this is useful is that when you get to number 1, you're going to identify what your power is for number 1. Your power is going to be that outside number. So n, or the power of your binomial, is 4. You add 1 to this to determine how many terms you will have, which will actually be 5. So if we're going to have 5 terms, you can go down each row and count how many terms there are. In the first row there's 1 term, in the second row there's 2 terms, so on and so forth. Or you can just count to the 5th row. 1, 2, 3, 4, 5. So you're going to be using these numbers. These numbers represent your coefficients when you expand your binomial. So you have coefficients of 1, 4, 6, 4, and 1. So then you're going to take the first part of your parentheses, which was 2a, starting on your first term, and raising it to the nth term, which was 4. So you have 2a raised to the 4th power. As you go to the right, you are subtracting 1 each time from the nth power. So the second term is going to be 2a to the 3rd, 2a to the 2nd, 2a to the 1st, and 2a to the 0 power. Now, for the second part of your parentheses, you have negative b. Let me change that to something lighter. So negative b, you're going to start at the last term, and you're going to raise it to the nth power, which was 4. Each time you move to the next term, you're going to subtract 1 from n. So the next one, you'll have negative b to the 3rd power, negative b to the 2nd, negative b to the 1st, and negative b to the 0 power. And then you can come in and simplify. So for the first term, multiplying by 1 does not change the value, so we can ignore it. Anything to the 0 power is 1. Multiplying by 1 again does not matter. So we have a to the 4th, a to the 4th, and 2 to the 4th. So 2 to the 4th gives us 16. Now we move on to the next one. The next one, we can pull out our variables first and then use our calculator for the rest. So we have a to the third. We also have b to the first. My suggestion to you during class was once you take your variables out, you can mark them out. Remembering that there's still a negative right here. So you have an understood 1 here in front of the b. So putting it into your calculator, you have 4 parentheses 2 parentheses to the third, multiplying by parentheses -1 raised to the first. Putting that into your calculator, you have -32. Again, for the next one. Again, my suggestion is doing your variables first. So you have a squared, b squared. Mark it out once you take care of them. 6, 2 squared times 2 squared times 1, -1 squared. And you would get +24. Going on to the next one, you have a to the first. And again, you don't need the 1 in the exponent. It's understood already. And b to the third. Mark it out. You have 4 times 2 to the first times -1 to the third. And you would get -8. And then lastly, you have multiplication of 1, don't care about it. You have something to the 0 power, don't care about it, it becomes 1. And then you have -b raised to the 4th. So bring it down your b to the 4th. Then you have -1 to the 4th. Well, -1 times -1 times -1 times -1. Negative times a negative is a positive, so you have 1. Over here, the last two, you have -1 times -1, which is also 1. So 1 times 1 is +1. So you have a positive b to the 4th. So there is your number 1. Number 2. Number 2 is a little bit more simpler. You can use your formula, or you can use your Pascal's triangle. If you want to use your Pascal's triangle, you would bring out your triangle again. You would look at your power. You have n as 5. You would add 1 to it to determine that you're going to have 6 terms. So you're going to be on this last row. And on your paper that you have access to, it asks for the 3rd term. So you're looking at this number 10 as your coefficient. So you're going to have number 10 out front. Now the first part of your parentheses was x squared. So your x squared in the first term is going to be x squared raised to the nth power, which is 5. Well, as you move to the right, it's going to go down. So this is going to be x squared to the 5th, x squared to the 4th, x squared to the 3rd. So we want our x squared to the 3rd. Now we also have this second part of our parentheses as 2y. So the last term of our line is 2y, and it's going to be raised to the nth power, which was 5. As we move to the left, it's going to go down. So 2y to the 5th, 2y to the 4th, 2y to the 3rd, 2y to the 2nd. So that is what we're going to use. 2y to the 2nd. So then we're going to simplify it. So we're gonna take out our variables. So a power to a power, we multiply. So 2 times 3 is 6. So we're gonna have x to the 6th. And then we're gonna have our y, so y squared. Mark it out as you go. So you will mark out your x's and you mark out your y. So you will have 10 times 2 to the 2nd power. 2 times 2 to the 2nd power is 4. Multiply 10 by 4 and you get 40. So that would be your third term for number 2. You could use your formula for this. If you need me to do this, please email me and I'll show you. For number 3, so we are given 5 different options for the floor plans, 8 for the exterior colors, and option of either 2 or 3 car garage. So all you need to focus on when it comes to the garages is that the 2 car is one option, the 3 car is the second option. So there's only 2 options for the garage. So the first options is 5, second option is 8, third option is 2. And you're multiplying the options together to get how many choices you have. When you do this, you get 80. And that's how many options. For 4, I've already done. Looking at it, it kind of looks similar to number 3. You have your first, second, third, and fourth letter. The first letter, you have 5 different options for your vowels. Once you use one of them, it cannot be repeated. So when you get to your second letter, you only have 4 options. Then 3, then 2. So you're multiplying them together. Now 5. Hey guys, again. So we stopped at number 4 and we're going on to number 5. So number 5, we are told that we have 4 digits. So our 4 digits is going to be represented by 4 little dashes. 1, 2, 3, 4. Now in our first little dash, we have 1, 2, 3, 4, 5, 6, 7 different options to have in the first dash. So we're going to put 7. Now, if the numbers, our choices, or what we're choosing from, cannot repeat, that means if we use, let's say, 8, we only have 3, 4, 5, 6, 7, and 9 to choose from. And those are 6 different options. And it keeps going. So let's say we use 4 for the second digit. Now there are only 5 options for the third digit. And then there's only 4. So once we have our different number of options for each digit, we're multiplying them to get 840 different possibilities. Similar for 6, there's 12 people that are entered in a race with 2 places that you're looking at. You have 12 options for the first place, 11 options for the second. So you're multiplying those. For 7, the difference in between 6 and 7 is that it doesn't matter the order. For number 6, it does matter the order. So this was actually a permutation that you could have used your permutation formula for. This one, it does not matter. It does not matter. Let's say you have your first 2 cards. One was a king, the second one was a queen. Doesn't matter if you had chosen or drawn the queen first, then the king second. Both of these outcomes would count as 1 because the order does not matter. So you are going to put into your calculator 52, choose 2, because the number that you can choose from is 52, and you're choosing 2. So you're going to take your calculator. If you have one of the older ones, you have to put 52 in first. If you have one of the newer ones, you don't have to, it just pops up. So 52, math, we're going to go over to probability. That's the unit we're in. And we're either going to choose 2 or 3. Well, because it doesn't matter the order, we're doing combinations, so we're going to use the C. And then the second number is 2, so I hit 2, hit enter, and that is my answer. So 1,326. All right, so for number 8, what is the probability of selecting a vowel when choosing a letter at random from the word functions? So some of you struggled with this. I think it's more of actually reading the problem. But we are not looking at the alphabet. We are actually looking at the word functions. So we are looking at vowels. In the word functions, we have U, we have I, and we have O. So that gives us 3 vowels that we can choose from out of how many letters are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9. So 3 out of 9, or 1/3, or 0.3 repeating, would be the probability of selecting a vowel. Number 9 and number 10 is written out for you if you want to pause it and look at it. Number 11, I want to show you how to look at this and try to create your own event. So mutually exclusive event. That means that situation A, whatever it is, let's say you pass a class, and situation B, you don't pass a class. These events are mutually exclusive, meaning that you can't do both. Now, an independent event would be if option A or situation A and situation B could happen at the same time. So similar to one of our problems that talks about a piano and a clarinet. You can play the piano and the clarinet, so this would be an independent situation. All right, so going on. For number 12, we are looking at the probability of one of the players or one of the students playing the piano. So that is 93 out of our total number of students, which is 135. We are talking about or the clarinet, so we're going to have addition. Then we have 63 that can play the clarinet out of our 135 students overall. So we have 36 over 135. and then we are subtracting the overlap, that is the 11 players that can play both. We do not want to include these 11 players in our probabilities that we already have down there. So we have 11 over 135. So this gives us a grand total of 118 over 135, or 0.874, which would round to roughly 87.4%. Okay, so then we go on to 13. So if you haven't come up to get help and not realize, I like to create different pictures to help you on these. So if you create a picture, in how many ways that can 4 of 7 different kinds of bushes be planted beside a barn? Well, you have your 7 kinds of bushes. So 1, 2, 3, 4, 5, 6, and 7. And your barn is over here. Now, what if you said you took your purple bush and planted it here, your orange bush, put it here, black one here, and your green one here? So that is one possible outcome. Now what it's asking is a combination or permutation, meaning does the order matter of where you plant them? In this case, it does not. So if we kept the same bushes, but just changed them around a little bit, so what if the green was now over here, orange over here, black here, and purple here? It would not change the fact that the purple, orange, black, and green bushes are planted. So in this case, order does not matter. So that means it is a combination. So that would be your answer. And number 14, it's another combination because the order does not matter. It does not matter which juniors, and if the 2 juniors are the first ones or the last ones or in the middle that are selected, or the 3 seniors. So for number 15, we are talking about Andy and Beth tossed a coin 50 times and got heads 24 times. Key thing, 24 heads. What is the experimental probability of tossing a tail using Andy and Beth's results? So what we want to find is how many times did Andy and Beth toss a tail? So we're going to do 50, subtract how many times they got heads to get how many times they got tails, which is 26. So the probability of them getting tails was 26 out of 50 tosses, or 3 out of 20, or 0.15. So for 16 and 17, I've already done. If you need to, pause it and look at it. Again, if you have any questions, please don't hesitate to email me. All right. Number 18, we are given a frequency distribution table. What this is telling us is that with all of this frequency, we get either 4, 5, 6, 7, or 8 size crews. So overall, if we do 3 plus 2 plus 30 plus 17 plus 27, we get a grand total of 79 frequencies. So what are the possible values of the random variable? We're told that the random variable is the crew size. So we have 4, 5, 6, 7, and 8. Then we're told to find the probability that our random variable is 7. So if our crew size is 7, what is the chances that it happens? Well, it happens 17 times out of the 79 frequencies. So this also can be 0.215. Now we're told to create a probability distribution table. So instead of having a frequency distribution table, now we want a probability. So all of our x's are the same. What might happen is 4, 5, 6, 7, or 8 crew sizes. The probability of getting 4, 3 out of 79. 2 out of 79. 30 out of 79. 17 out of 79. And then 27 out of 79. Then we're told find the expected value of the probability of x. So how we set this up is what can happen times the probability of it happening. That could happen, or 5 could happen, and we're going to multiply it by the probability of it actually happening. Or the 6 could happen, and we're going to multiply it by the chances of it happening. Or a 7 could happen, multiplying it by the chance of it happening. Or 8 could happen with a chance of 27 over 79. So when we put this in the calculator, we get 6.797, which means it is expected to on average have 6.797 members in the crew. Again, if you have any questions, please email me or message me so I can help you study.